Another u substitution. No matter what you choose for your u, you better be sure that you have a du in your integral somewhere. So I'm going to choose u to be negative x squared, giving us a du of negative 2x dx. Noticing that I have an x dx in my integral, I'm going to divide this equation by negative 2, giving me that x dx is a negative 1/2 du. I'm just going to rewrite this integral so we can more clearly see what our substitution looks like. This term right here looks like a negative 1/2 du, and this first term looks like an e to the u. I think that that's something that we can integrate, so I'm going to go ahead and talk about the limits. The limits on the given integral go from x equals 0 to x equals 7. When x equals 0, using our substitution here, you'll notice that u is also 0. And when x equals 7, you'll notice that u would become negative 49. So our lower limit of integration is going to stay as a 0, and our upper limit of integration is going to be negative 49. Let's complete the substitution. We can pull a negative 1/2 out of this integral, and we're just left with an e to the u du. Integrating that just gives us e to the u. And now the fundamental theorem of calculus part 2 says that we can plug in our upper limit of integration, we can subtract, and plug in our lower limit of integration. That is going to simplify to negative 1/2 e to the negative 49th power plus a 1/2 e to the 0, of course, is 1. And that looks like a pretty good answer. If you really wanted to, you could have left the 1/2 outside. Factoring out a negative 1/2 would give us this result. Either way should work, and I like that one. I think that was a pretty good problem.